This clip discusses the PARMS cost modules. Before that, it's worth recapping the Network Explorer. As we've discussed in the other video, the Network Explorer is the way that we interrogate and visualize data. We access various queries and folders through the Explorer tree. Each query is set up using a query controller, which can be a simple or advanced version. We save the queries, which allows us to run those queries, and that brings up assets and failure data into the software for interrogation and use in our analysis. So moving from the Network Explorer, we can go over into the cost models. Again, the costs are built up in a tree-like structure. The master costs represent the costs that are agreed to be used by the utility, but we can build up our own cost models for our own purposes. Again, to do that, we can either right-click in the panel and bring up a new costs, or we can click the icon. So now I've created two new cost models. I can rename those, and for the purposes of this, I'm just going to call them test 1, 2. One of the reasons that you may build up a different cost model is because you might change the consequence model or include different elements of cost or exclude them for different purposes. The widget here can be used to compare two cost models. So simply by selecting the two costs, press the button, it will come back and tell me what the difference is between the cost models. So you can see here there's no differences. If, however, I go into the cost model and just change something, so maybe I will change this to $1,000. Now, if I compare those two cost models, I can see that the comparison comes back with the difference that I have just imposed. The cost model also has a range of elements to it. So if we go down those in turn, you can see that we have to specify the costs for clamping repairs and non-clamping repairs, and the costs are broken down according to area classification, nominal diameter, and surface type. So I might have a pipe in the CBD under a major road, which is a large pipe. I would expect the repair of that pipe to be more costly than a small pipe under a verge. It's reasonable to assume that the cost associated with each grouping is the P50, the expected cost for repair of a pipe in that particular situation. So we have the repairs broken down into area classification, nominal diameter, and surface type. We have the cost of trench replacement, again broken down according to those same criteria. The cost of trenchless replacement. Then a range of costs that may not be used in your analysis, but that are there for flexibility. So things like cost per interruption, some penalty setting, some social costs to reflect customer interruptions and traffic, a module that allows some flexibility in the way consequences are set up. In a full analysis, Wiser and the utility will work together to set up the consequence model, and that will be used as the base for the analysis. But where that's not done, or as an alternative, there are options to specify, for example, a criticality-based consequence, where the consequence is related to the criticality assigned to a pipe. So in this particular case, I have specified that the repair cost multiplier is going to be used based on the criticality. This reflects rules of thumb used in the industry. Valve costs are important from the perspective of setting up pressure management schemes. The suburb cost just allows flexibility where there are spatial differences depending on, say, suburbs or councils. Other costs are to do with failures that don't drive the renewal of pipes. PARMS also allows you to set up flooding models to look at the strategic implications of flooding across the network and also the cost of water loss.